Okay, now we're going to look at complex numbers, and I want to warn you that we're now looking at the complex numbers, and this is going to be very similar to when we were looking at vectors earlier, but realize this is different. Vectors had magnitude and length, whereas here our complex number is just referring to a specific point, and our complex numbers, if you recall, are in the form of a plus bi. And we're going to designate this as z is representing our complex number, where a is representing the real part and b is going to represent the imaginary part. And if we look at this on the complex plane, then we have the x-axis is really our real part and the y-axis becomes the imaginary part. So if we had the complex number, let's say that z was equal to a negative 2 plus 3i, then that means we would go 2 to the left on the real axis. That's kind of our x-axis. That's the real number. In the imaginary part, we would go up 3 on the y-axis or the imaginary axis, and we would simply have a point. Now, once again, realize this is a point. It is not a vector, so it's just a single point. It doesn't have the magnitude that we talked about when we were looking at vectors. So if this is our complex number, negative 2 plus 3i, then we can actually look at what is going to be the magnitude, I'm sorry, not the magnitude, what is going to be the absolute value of this number. So how can we find the absolute value? Well, we think about normally if you look at the absolute value of just a real number, the absolute value is how far away that number is from 0. So if you took, for example, the absolute value of 5, how far away from 0 is 5 located on the axis? Well, the answer would be 5 units. If we take the absolute value of a negative 5, how far away from 0 is negative 5 located? And once again, that would be a positive 5 units. So here we're going to do the same thing with our complex number, but instead of looking at how far away from 0 our number is, we're now looking at how far away from the origin here at 0, 0 are we located. So in order to do that, that's going to allow us to find the absolute value of a plus bi. And the formula for that is simply going to be the square root of a squared plus b squared. Now, why is that? Well, if we go up here and we look closely, if we were to think about drawing a line out to this point, and then if we were to go down, we actually form a right triangle. So therefore, we have this side as a negative 2, this side is a positive 3, and then how can we calculate this hypotenuse, or the r value? Then we can certainly just look at that by taking the Pythagorean Theorem. So again, this is looking at r squared equals a squared plus b squared. So that means r is going to equal to the square root of a squared plus b squared. And that's going to find this value here, which is the absolute value. So if we were trying to calculate the absolute value here for negative 2 plus 3i, so here absolute value of negative 2 plus 3i, then that would be simply the square root of a negative 2 squared plus 3 squared, and we would end up with 4 plus 9, which would be the square root of 13. So here, how far away from the origin is this point? And that's going to give us the square root of 13. That's the absolute value. All right, here we have our complex number z equals a plus bi. This here is considered to be our standard form. And we now want to look at how can we rewrite this complex number from standard form into what we call trig form. So to look at that, we're going to look at we're going to pick just a number here, and I'm going to use a, b. So in other words, if we were to go over here some distance, and we'll go to this side, if this was some distance a, and then we were to go up some distance b, and then we would have, of course, r. So the point up here, our complex number then, or this point would be a comma b. And we want to keep in mind this is the real axis and this is the imaginary axis. And then of course we would have some angle theta to get over to this location. And we can kind of think of this again like our unit circle. If R was 1 unit, then that would be our unit circle here. And we could certainly then rewrite z equals a plus bi as z equals r cosine theta plus I r sine theta. Now you're going to notice here, normally up here we put the I after our number, but anytime I'm using a trig function here, I like to put the I in front because if you were to write sine theta I think this looks a little more confusing. So you'll notice that when I have a trig function in the imaginary part, I like to put the I in front of the trig function. I just think it looks a little bit nicer. So this here, we know that if we have cosine theta plus sine theta, that gives us the point on the unit circle. And then if we take and multiply that by r, that's going to give us the length, or kind of this length here of how far that point is away from the origin. So that's kind of multiplying it by the absolute value. Another way to write this is we have the r value. We could certainly just factor out the r value, and we could write this as z is equal to r times cosine theta plus I sine of theta. Okay, and this here is your trig form of a complex number. So here we have the trig form, and up here we have our standard form. And now what we're going to do next in the video is we're going to look at how we convert from standard form into trig form. Then we're going to look at how we can go from trig form back to standard form. So our first example, we have z equals -1 plus I square root of 3. So this is our standard form. We have a plus bi. Okay, and we want to change this into trig form. Now, if we go back up here and look at our trig form, there are a couple things we need to know. Well, to go to trig form, we need to know r. Okay, and remember r is this point over here, or the how far our point is away from the origin. And we also need to know the angle theta. So that is simply how far we are around to our location. So first of all, how can we find r? Well, we said r is simply the absolute value, okay? And again, that's just using the Pythagorean theorem. R is the distance we're away from the origin. So we simply have a right triangle, and that's going to be our absolute value. So first, let's find how far away we are from the origin. And to be helpful, let's go ahead and plot our point. That's probably the first thing we should do. We have a -1, so here's our real axis and our imaginary. So the -1 tells us we're going to go a -1 to the left, and then we have a square root of 3. So we know that's going to go up, and I'm just going to pick a point here and call this the square root of 3. So we're going over. So our point is right here. And what we need to first calculate is, what is this r value? How far away is that? Well, again, that's just going to be using our Pythagorean theorem, because we know this is a -1, this is the square root of 3. So then r is equal to the square root of -1 squared plus the square root of 3 squared. Okay, and then we're going to get r is equal to 1 plus 3, so that's going to be the square root of 4. So the square root of 4 then is equal to 2. So there we already know the r value. So then our second step, we need to find the angle. Well, if we look at this, we're trying to find our angle, so how can we calculate this angle? Well, remember we know that we can think of tangent of theta. That deals with our y over x, right? So we can think of tangent theta is equal to y over x, or in this case, we can think of this as kind of our x value here, this is our y value. In terms of our complex number, the a is your kind of x, the b is kind of your y value, so we could actually write this and think of it as tangent theta is equal to the y value, which is b, so that would be the b part, the imaginary, over the real part, which is a. So we can think of tangent theta is equal to b over a. And if we're looking for the angle, then we would just simply say the tangent of theta is equal to b, which is the square root of 3, over a, which is -1. And then in order to find theta, we would have to take the inverse tangent of square root of 3 over -1. So if we go to the calculator, and of course square root of 3 over -1 is just simply, we could just think of this as a negative square root of 3. So going to the calculator, and for this one I think I want to go ahead and work this in degree mode. If we had radians, our angle would come out in radians, but for now let's stick with degrees. So we're going to go second tangent, and we would have then negative square root of 3, and we get an answer of -60. So therefore our angle is a -60 degrees. Now a -60 degrees we know is going to be down here. And again, this goes back to the whole domain and range with the inverse tangent. So we know our angle is not a -60 degrees, but what that tells us is that up here, this angle must be 60 degrees. So therefore, if we're looking for this angle, the angle theta we're looking for has to be 180 degrees, because all the way over here is 180. So we would have to take 180 and subtract away our 60 degrees. So therefore we know our angle is going to be equal to 120 degrees. So this is 120. We know r. We said r here is equal to 2. So now we can come up with our trig form. So that means we would have z is equal to, and our formula says what? R cosine theta plus I sine of theta. So for us, that means z, which is the complex number, the r value of 2, cosine of 120 degrees plus I sine of 120 degrees. And then, of course, if you wanted to, if you went to your circle, we had this in terms of degrees, you could go to the unit circle, and 120 degrees we would find would be the same as what? Well, 120 degrees would be the same thing as 2 pi over 3. So we could certainly write this as the cosine of 2 pi over 3 plus I sine of 2 pi over 3. So either one of these would be correct, depending on whether you want to be in degrees or radians. So let's look at our next example. And here we have the standard form of -5i, and we want to rewrite this once again into our trig form of a complex number. And it may be helpful, remember our trig form is a plus bi, so we may think of this as being 0 minus 5i. So here, if this is our a plus bi, we realize that our real part is 0. We only have an imaginary part. And once again, I would suggest actually plotting this point just so that we realize where this is located. And if this is our real axis, we have this is our imaginary. So of course here, negative 5i means we're just simply going to go straight down 5 units here on the imaginary axis. And now, if we want to put this in trig form, once again, we need to calculate how far this is from 0. So we could go to our same formula, r is equal to the square root of a squared plus b squared. But in this case, a is simply 0, so we would have 0 squared plus negative 5 squared. And that just means we're going to square the 5, so that's going to be a positive 25. So we get the square root of 25, which is going to equal 5. And if we were smart enough, we could have just looked at this and said, well, this is straight down. We know this is going to be 5 units. All right, then just like before, we need to now calculate the angle using our tangent function, which in this case, we would say the tangent of theta is equal to y over x, or in this case, it's going to be b over a. So our b value is negative 5 over a, which is 0. And here we should realize that this is division by 0, so therefore our tangent function is going to be undefined. And we have to think, where on the unit circle is our tangent function undefined? Well, it's going to be undefined anywhere we have division by 0. And if we look at our point, we can easily tell the angle. Once again, we really didn't even need to use the tangent, because we know this angle to go all the way around to here is going to be located at 3 pi over 2, or 270 degrees. Okay, so therefore we have r, we have the angle, so we can come up with our trig form by simply saying z is equal to r, which is 5, and then that would be the cosine of 3 pi over 2 plus I sine 3 pi over 2. So there we have our trig form of our complex number. Okay, next we want to look at going the other direction. What if we're given the trig form and we want to convert it to standard form? So let's say that we're given the following complex number in trig form, 5 cosine of 135 degrees plus I sine of 135 degrees. Well, this is going to be really easy. All we have to do is either use the unit circle or possibly use our calculator. So here we would just say that if we have 5 times the cosine of 135, well, if we go to the unit circle and we're going to locate where is 135 degrees, and that's going to be located right here. And what's going to be the point? Well, the point at 135 degrees is going to be a negative square root of 2 over 2 for the x, and a positive square root of 2 over 2 for our y value. So therefore, if we were to take the cosine of 135, we're going to get a negative square root of 2 over 2. And then if we take the sine of 135, that's going to be the y value. So here's your x, here's the y, and that's going to be a positive square root of 2 over 2. And again, this part here would be the imaginary part, and I guess you could write it here, but normally I will write the I in front of a square root just like I do the trig function. So therefore we have 5 times negative square root of 2 over 2 plus I square root of 2 over 2. And at this point we could actually distribute the 5, and we would make this a negative 5 square root of 2 over 2 plus 5I square root of 2 over 2. And this here is our standard form. And also we'll notice here, by using this technique, this here is what we would say is the exact value. In other words, we didn't change it to a decimal. This is the exact value. Now, if we wanted to, we could actually put this in the calculator and we would come up with an approximation. For example, we could have just gone from here to here by using the calculator. We could have said 5 cosine of 135. Just make sure again that our calculator is in degree mode. And if I said 5 cosine of 135 degrees, notice here we would get a negative, and I'm just going to round this, negative 3.53, negative 3.53, and then the same thing for the sine function, so we say 5 times the sine, so we would have 5 sine of 135 degrees, whoops, 35, and we get a positive 3.53. And of course, this one would be our imaginary part, so therefore it would be 3.53i. And here we have the standard form, but this would be an approximation. So whether you're looking for the exact value, that means we could actually find the point on the unit circle. Otherwise, we would have to use the calculator to find an approximation for the cosine and the sine. And here it should make sense that we notice that these values are the same. It's just that one's negative and one's positive because this point is located at this 135 degrees, which cuts this into the 90-degree angle here in the second quadrant. It cuts it exactly in half. So we have 45 on top and 45 below, and that's why the x and y coordinates are the same. It's just the x is negative because we're going to the left. The y is positive because we are going up. All right, I have one more example, and we want to actually change this trig form into standard form. So if we have 6 cosine of 5 pi over 12 plus I sine of 5 pi over 12. And if we want to convert this from our trig form into standard form, once again here, we could actually think about where this is going to be located first, possibly. We have an angle of 5 pi over 12, which if we go to the unit circle, we don't have 5 pi over 12. Now, the question is, where is this angle located? Can we determine where 5 pi over 12 is? Well, if this was 6 pi over 12, we know that this point at the top here is pi over 2, and 6 pi over 12 would be the same thing. So 5 pi over 12 must be right about here. So we're trying to figure out what would be the coordinates here. And of course, we have the r value, which is 6, so that tells us this has a distance of 6 from the origin. And the only way we can do this is to actually use the calculator as in the previous example. So we're going to take 6 cosine of 5 pi over 12. But before we do that, we have to make sure that we go into the mode and change that into radians. So once again, we would just go 6 cosine of 5 pi divided by 12, and we get 1.55. And then we need to do 6 times the sine of 5 pi over 12. 6 sine of 5 pi divided by 12. And we get 5.79, so if I round that, that'll go to 5.80. And again, that's the imaginary part. So here, all we can come up with is an approximate answer. And if we look at this closely, would make sense that this is going over here, roughly the 1.5, and then up here on the y, this looks like this could certainly be 5.8. And that indicates we are going to be here at this point in the first quadrant. So once again here, dealing with your complex numbers, make sure you understand the absolute value, which is basically just using the Pythagorean theorem. The square root of a squared plus b squared is the distance we are from the origin. And then, of course, if we want to change this standard form into trig form, all we have to figure out is the r value and the angle. And in order to do that, we simply use the absolute value, the Pythagorean theorem, and our tangent function of either y over x, or in terms of the complex, we can take a tangent as equal to b over a.